Hello everyone. Today we are focusing on comprehension type questions. Typically, you will be given a passage or a sequence of reactions to analyze before answering a set of questions. For this video, I have selected a sample with two specific questions. Please pause the video now and summarize the information and work through the solution on your own. If you need guidance, just follow along as I explain the process. Stay tuned until the end for a bonus challenge and share your results in the comment section. So let's get started. 1 cyclopropyl ethyl acetate upon heating forming two products A and B. B is an acid and further it is not undergoing any reactions. Whereas A is undergoing two types of reactions. When A undergo reduction in presence of nickel, it's forming two products C and D. From the information given here, you know that they are hydrocarbons and they are isomers because product C is having three types of hydrogens and product D is having four types of hydrogens. That means what? They are structural isomers. With the help of this much information, you can solve the first question. When A undergo rearrangement upon heating, it is forming product P, which on treating with alkaline KMnO4 at 0 degrees Celsius undergo oxidation to form the product F. You can answer question number 2. Now let's write down the reactions and answer the given two questions. The first thing you do is convert this IUPAC name to the structure of the molecule. Without that, you can't solve this question. Acetate means what? It is an ester. So for esters, how do we write the structure? Since it is acetate, there will be two carbons, so CH3COO like this. And then we look at the alkyl part. There are two alkyls here. One is cyclopropyl, the other one is ethyl. So which part is directly attached to oxygen? First, you take this one, ethyl. Ethyl means what? CH2CH3. And when you number these carbons like this, 1 and 2, at the first position, there is a cyclopropyl like that. So you have to remove one of the hydrogens and write the cyclopropyl here. So this is the structure of 1 cyclopropyl ethyl acetate. You can call this as ethanoate also. So this ester upon heating means what? This is a pyrolysis reaction. So what is pyrolysis reaction for the given ester? Let's write the mechanism. From the question, you know that the first reaction is a pyrolysis of an ester. When an ester with beta hydrogen is heated at very high temperature, say around 400 to 500 degrees Celsius, it always forms an alkene and carboxylic acid. That you should know because in the question it's already given that B is an acid and A is alkene. So what are the structures of these alkenes and acid? You can predict that only when you know the mechanism of the reaction. So let's write down the mechanism of the reaction. So I'm writing bond line structure for the cyclopropyl ethyl acetate molecule because it's much easier this way. When this is heated, the beta hydrogen, so this is alpha carbon, this is beta carbon. So the hydrogen attached to beta carbon is beta hydrogen. So it starts interacting with the oxygen present here. That means what? It is forming a transition state which is 6-membered ring. So these are quite stable. Then what happens ultimately? There is a breaking and making of bonds. So where all the bond will break here? So these pi electrons are given to the hydrogen. This bond will break. That means between alpha and beta carbon, there will be a double bond. Because of that, what happens? This carbon will become pentavalent. So it cannot withstand the electrons. Then what happens to this bond? It will break and it will be given to this carbon. Then based on the arrows you have written here, you have to write the product. So how do we do that? Check out here. This double bond has become single bond and there is a new bond formed between oxygen and hydrogen, and then There is a double bond between carbon and oxygen. And what is this? This is a carboxylic acid. Nothing but our product B. It's ethanoic acid. Now, what about this part? Between alpha and beta, there is a double bond and it is attached to cyclopropane like this. It's a cyclopropyl ethene molecule. That is nothing but our product A. It need not to be necessarily major product. It is not applicable here, okay? Because if there is 1 mole of product A form, there will be 1 mole of B also form. So you can ignore this part here. What is happening to A? It is undergoing either rearrangement or reduction. Reduction reactions are quite simple. So let's do the reduction part and see what will be the correct answer for question number 1. So when cyclopropyl ethene molecule undergo reduction, and you can see there is an excess of hydrogen. That means what? The first mole will definitely add to the double bond and then it will add to the cyclopropane part also. Why so? Because cyclopropane is having a lot of ring strain in the molecule. Because of this, it is ready to open up. So what all products you are going to get? So this is getting reduced. Okay. So let's assume if the bond breaks here and the hydrogen adds here and then here, right? Then what you are going to get? You just have to write like this. This bond is broken, right? And then like this. And what is this molecule? This is nothing but a pentane, N-pentane molecule. Say, let's assume that I'm going to break this bond because we don't have any control on these reactions because they are generally a free radical reaction as it is happening on catalyst like nickel, right? So then what happened? See here, this will remain as it is. Since I'm breaking this bond, you can write like this, right? How many carbons are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is nothing but isopentane. Pentane, isopentane. So structural isomers. And which is what? Which is C, which is D? For that, let's use this information. Product C is having 3 types of hydrogens. So this is having more symmetry. So less type of hydrogens will be there because CH3 will be same, CH2 will be same, and this CH2 will be same because of the plane of symmetry in the molecule. So this is having 3 types of hydrogens and this is nothing but product C. C is N-pentane molecule. So what will be D? Obviously this one. How so? Look at these. These 2 are 1 type of hydrogens and this is 2, this is 3, this is 4. So there are 4 types of hydrogens. Isopentane is D. Now let's verify what is given in the options. Can it be methyl cyclobutane? No, not possible. D is a N-pentane. No, not correct. C is a N-pentane. That is correct. Therefore, the right option is option C. C is isopentane. Not correct. D is isopentane. So, the only correct option here is option C. Now, let's solve for the second question. The second part of the question is about the product A, which upon heating, it's undergoing rearrangement. Say, let's assume you don't know what sort of reaction it will undergo. You can still use this information about the rearrangement and predict the product. How so? When there is a rearrangement, the number of atoms will remain same. That means the molecule is undergoing isomerization. How this molecule can undergo isomerization? One possibility is that it can undergo ring expansion because the cyclopropane molecule is not stable due to ring strain in the molecule. It's always ready to open up the ring. Because of this, there is a ring expansion. That means what? It can expand to a 5-membered ring. Why so? Because we have additional 2 carbons. So when they get involved in this ring, so we are going to get a 5-membered ring. Do we have a 5-membered ring as an option here? Yes. So the answer is option D. But how to get that as a product? Let's write the mechanism. So in rearrangement, there will be breaking and making of bond within the molecule and they are concerted mechanism. So because the pi bond is electron rich, when it moves here, this carbon will become pentavalent. So it cannot withstand that and it has to break the bond either here or here. It doesn't matter because it is symmetrical. Say let's assume it breaks over here, and where these electrons will go? It will go to this electron deficient carbon. And then what are you going to get? Just follow the arrows. That means what? You see these bonds are fixed. This carbon is bonding with this one like this. You write down like this. And what is happening to the double bond? The double bond is moving here. Structure doesn't look correct. So we can write this molecule properly now. Look at this. 1, 2, 3, 4, 5. Right? So 5-membered ring. And between any two carbons, you can write the double bond. If you're not comfortable writing the structure of the product in one step, I'm going to give you one more trick here. How you can write? You can polarize the bonds. What do you mean by polarizing the bond? Say, let's assume you have this carbon-carbon bond, right? Break it open, right? Because there is a breaking and making of bonds. And one carbon you write negative, the other carbon you can write positive. Because this is positive, the pi electrons will move here and this carbon will become electron deficient, means this will move over here. Then what you can do? You will get a structure like this, which is nothing but the cyclopentene molecule. So what is that? It is nothing but product P. And this product P is treated with alkaline KMnO4 at lower temperature. That means what? This is formation of a dihydroxyl compound. So this is oxidation and it is forming a diol product. So usually we are going to get a cis product like this cis diol because addition of KMnO4 across the double bond is always a syn addition. That's why. So we are going to get a vicinal diols which are cis to each other. Hence, the final answer is option D. So students, what we have done, we have taken the ester and we have done a pyrolysis reaction which forms an alkene and an acid. You can ignore this acid part because it's not undergoing any further reaction. So this alkene upon complete reduction of the double bond as well as the cyclopropane, you are going to get two structural isomers, isopentane and N-pentane. So the N-pentane is product C and isopentane is product D. Other part of the question is that the A is undergoing rearrangement because still we have a reactive center, that is an alkene and a cyclopropyl. So it's undergoing ring expansion. These are quite common. So you should know that such molecules can easily undergo ring expansion due to ring strain in the molecule. So it's forming the product P. P upon oxidation with alkaline KMnO4 at lower temperature is going to form a cis diol because it is a syn addition. Hence the product is option D. So this is how you have to solve a comprehension type of question. And if you still have any doubts on this question or any other question, you can comment your queries in the comment section. I will help you with that. And don't forget to solve the question given at the end of this video. And please do subscribe the channel if you haven't done it. Thank you.